Okay, great. Well, welcome to the fourth meeting of the CBIA. Yeah, we have a couple of people that couldn't make it, but hopefully they'll join later or they'll catch us on with the recording. Let's jump right to the agenda. So we have three main topics for the agenda. So we have a presentation. Are we recording? Can you confirm, Lucas?
Yeah. Yes, we are recording.
Yeah, I can see the icon, that's why.
We have the assistant, Airgram assistant on the call.
Ah, that's the one, okay.
That's where I downloaded from.
You're using modern technology, okay. Thank you.
Yes, it also, yeah, does the transcript.
Okay, sorry. I was used to the little round red box.
Thanks for checking, of course. Yeah.
Yeah, no. So first part of the agenda, we have Arnaund Bailly from the head of architecture at IOG. Is going to be presenting Mithril for us. That's really exciting. And then for the rest of the call, we'll have a small discussion about the Cardano Summit. So I think there's a good opportunity for the CBIA to have some kind of presence at the conference, either organizing, a panel or workshop or some kind of discussion. So it's nice to see who would first be attending to that summit and what we could organize. And lastly, we want to talk a little bit about this operational kind of tasks for the CBIA and governance. Right now, as we mature and grow as an organization, I think we want to kind of also discuss a little bit how we want to organize ourselves. Right now, we've been doing all these monthly talks, and I think we can mature that a little bit and self-organize a bit better. And so Lucas has prepared a little proposal for us, a little discussion, which he'll go into at the end of the call. So that's the agenda. And now let's start with the first items. So Mithril, Arnaud, yeah, take it away.
Thank you. So yeah, I'm going to give you an intro about Mithril. The idea is I will keep it short, so something around maybe 20-30 minutes, not much. I guess that should be fine, or maybe less. Just tell me when I run out of time. The agenda is why. We always start with why. So why Mithril? What's the point? What are we trying to achieve with Mithril? What it is? So basically, what's the, I would say, theory around it and how it works. I will try to give you a short demo on at least on the client side and give you a tour of what's available, and then give you also a bit of information about what's next. What are the next important milestones for the project, and give you a conclusion. This is me. We don't really care. Why Mithril? We all know that. We have the thanks to the network. The whole point of the blockchain is to provide security across a distributed setting between nodes that are potentially adversarial. And from the point of view of every node, you provide that security through a replication mechanism and a distributed consensus mechanism based on stake. So that's what I try to represent here. This is the basic architecture of the Cardano network, which I guess everyone is familiar with. The block producer have stake in the system, whether their own stake or delegated. And then there is an interconnected network of nodes. Each of those nodes contain a chain, which is replicated across all the nodes from the block producers, which are the one producing blocks. And that's the basic blockchain 101 mechanism. And this security is so to get the full security of a network, well, you need to be part of the network, which means that you need to run a full node. And that's very well known in the ecosystem and in the industry. That's the highest level of security you get is from the node. And the reason why you get that security is because you are applying the full consensus rules. You are using the consensus and the network and the fact you are part of the network to evade potential Eclipse attacks or CBIA attacks or any kind of other attacks that people could make. This is great, but this is slow. We all know that synchronizing a node with the chain takes a while. So this is a graph I made like a few months ago. So probably the graph is now extended, or maybe not. I mean, it depends on the improvement I made, but give or take. So here we can see that something around like 18 hours, more or less. Yeah, I guess so. Yeah, something like 18 hours. A bit over 18 hours to get a node fully synced from nothing. And yeah, I guess that's also something which we are very familiar with. And when you synchronize a node from scratch, then basically you need to wait 18 hours before getting ready to have a fully operating node and fully secure, because you get the information and it takes time to verify the information from the network. Therefore, the first use case for Mithril that we had started working on last year was very focused on how can we provide fast bootstrapping for Cardano node. And that's the idea that obviously you want to be able to, in various circumstances, it could be for testing, it could be for development, it could be on various different networks, it could be whenever you want to run a full node for your own use cases, whether it's a Daedalus wallet or a full node wallet, or whether you are maybe spinning a new node because your application requires new node. For example, I am also working on Hydra, and Hydra being layer 2 requires interaction with layer 1, with the Cardano node. And now the question becomes, oh yeah, but what if I want to run Hydra, but I don't have a Cardano node available? So do I use the Cardano node from someone? Yeah, of course, I could that, but we all know that this is potentially a security problem. And also from the point of view of a Hydra node, being a layer 2 and to provide the full security that the layer 2 is supposed to provide, you are supposed to be online, and online means connected to layer 1 and connected to a full Cardano node. That's the guarantee of Hydra. So this means that, for example, we could imagine, and I won't demonstrate that, but we could perfectly imagine that we could combine the two technologies to say, well, you could be able to run a fast to build a cluster of layer 2 Hydra nodes connected to each other, with the full security by being connected to the Cardano layer 1 network, by combining Hydra and Mithril, and using Mithril for bootstrapping the node, and using Hydra for providing the fast interactions of the transaction. Of course, this is not the only use case. There are other use cases being explored, and more than explored, being scheduled to be worked on, like more secure light wallets, where you want to have your cake and eat it too. So you want to have the full node security, but you don't want to download 200 gigabytes of data. So can you do that? Yeah, you can do that, sort of. You can do that by potentially downloading Mithril, when Mithril will be able to provide you only the information that's relevant for your wallet, basically, and being able to provide, and we'll see that at the end of the presentation, we are also working on the ability to provide fragments of the state, like, for example, a UTxO Merkle tree, where you could pick and choose, just in the same way that the filtering for SPV works on Bitcoin. Other use case being explored, so voting systems. This is something quite concrete that people have started working on, especially in the context of the CIP 1694. So probably not in the first situation, but in the long run, Mithril could provide a way to provide you or any voters, for example, or any voting system to provide a certified stake distribution, which gives you the ability to know exactly and to know that, with the attached security, required level of security, what is the voting power of all the parties. And now you could perfectly be able to use that as a way to aggregate votes to securely aggregate votes. Other potential use cases which are explored are also in the context of the future rubles Legos, where Mithril certificates could be produced for I never remember, I think the input blocks or the other blocks. So the blocks that actually contain the data, which will be, because in Legos, the two blocks are separated. You have like the consensus blocks, and then you have like the ranking blocks, and then you have the input blocks. But the input blocks, which actually contain the data, would be signed by Mithril certificates that could be produced on a regular basis to provide a way to actually validate that the blocks are correct. And we even are discussing Mithril in the context of sidechains, where you could use Mithril in either direction, either as a way to, with a sidechain, using the stake or using the native currency of sidechain to provide a certified state for the sidechain, or the other way around, using the ADA bridge, the ADA staking to provide certifications in the bridge and for the sidechain. So yeah, I will focus this presentation, and this is really we really wanted the team and the development to be really focused on a single use case to make sure that we do it and we deliver something and it works, and then we embark into something else. Of course, while keeping in mind that there will be other use cases. So what is Mithril? I mean, this is initially a research paper from Piero Kaidos and Agelos Kayas, which are researchers at IOG. And as you can see, so the name is a stake-based threshold mostly signatures. So in general, the Mithril is a very general algorithm that basically provides a way to give you certified secure multi-signatures, but not by aggregating naively all the signatures of a bunch of signers, but by taking into account their relative weight and the stake, and to only require certain thresholds of signers to provide a signature to be valid. And so if you're interested in that kind of stuff, go read the paper. It's pretty dense, I would say, and it provides all the mathematics and the primitives defining and explaining how the algorithm works, and also the theoretical justifications and a few numbers in terms of, okay, what are the required parameters to provide some level of, depending on the usual assumptions about the addressable stake, what are the required parameters and the required number of signatures to provide a level of security which gives you infinitesimally small probability of being able to fake the signature. And actually the numbers are not that large. So it's not like, and what's interesting, and the real value of Mithril, of course, the fact that you don't require actually that many signatures. You don't require like, I don't know, 80% of the signers. You actually require much less. And a few hundred signatures are just fine. How this is accomplished? Basically, so this is a screenshot from the website that we show you later from the Explorer. There is a Mithril Explorer that we have set up to try to show the technology and to have a running demo. So the main parameters of the algorithm are this the protocol parameters, which are tweakable, and depending on the number of participants, the stakes, the evolution of the system, they will be tweaked. And basically, it works by drawing at random lotteries across the whole stakes, and you in this particular case, you draw each signer will draw 100 lotteries, and they, depending on their stake, they will win, or they will get winning tickets. And this protocol parameters requires number of winning tickets to be 5. And of course, this is not the right number of parameters. The parameters for the mainnet will be much larger, but this gives you an idea of how the mechanics works. And the F value is actually the VRF parameters that is used to compute how likely you are to win a ticket when you run the verifiable random functions and you provide your lottery ticket. So it's all based, ultimately, it's all based on VRF, or kind of VRFs that that provide you an unforgeable proof that, yeah, you actually win this lottery ticket and you are legitimate because you can sign this lottery ticket. Other interesting things is like what's interesting in Mithril is that the what to snapshots is completely independent of the who and who will provide the signatures, which means that we are now focusing on the being able to snapshot the state of the chain. So the whole chain adds some epoch number with some immutable file number, but it's not very hard to imagine that, yeah, we could provide anything that basically is a random bunch of bytes, or a hash of a random bunch of bytes, could be signed by the signatories. What we see here is that in this particular context, so we see that we have like the stake pools. So the stake pools are the participants in the Mithril signing process, and those pools can win some tickets, and we display here the amount of stakes that each of them has, and we show here the hash of the previous certificate. Just like the chain, like the main chain, you can see that the certificate is identified by its hash, and it's linked to the previous hash, to the previous certificate, down to a Genesis certificate, which is signed by the Genesis keys of the network. So right now it's a made-up Genesis keys because we are in testing, but later on it will be the actual Genesis keys of the network. That's the idea. And then so this idea of a certificate chain means that just like a blockchain, the whole security of the system depends on the ability to construct a valid chain of certificates. Each of the certificates are signed by the parties, by the SPOs, or more generally, the signers, which owns a certain fragment of the stake at some epoch. And what they sign, it's what's interesting interesting. I mean, I don't want to go into all the details, of course. That's something you will be able to look after. But what's interesting in the certificate is that this certificate also contains, so it contains a bunch of signatures. It contains the message that you want to sign, and it also contains the stake distribution that will be enforced for the next epoch, the next signing round. And this means that basically you are saying, okay, at some epoch we are signing a certificate, and we are signing a certificate saying that the next stake distribution will be such and such. And then when you cross the epoch threshold, this is this new stake distribution which is in place, and now you can use that stake distribution to provide the signal, and this provides a chain of validity for the Mithril signing process. What's the team? So this is a Mithril protocol part, which is the crypto focus part of the system. It's very generic. It's a cryptographic algorithm that, given some stake and some parameters, gives you produce you a certificate and or multi-signature, and that this multi-signature can be verified. So this is really independent of what we sign and how this is put in motion. What the team has been mostly working on is on the actual Mithril network. So the Mithril network is actually all the actors that will be linked together to build the certificates, provide the snapshots, and then of course use the snapshots. So the main three actors are, at the core we have the signers. So the signers are here on the left, the ones that are, so they are the SPOs. What they do is that basically they need to stay close to a Cardano node. They need to own the secret keys, which are the case keys, the case hotkeys, which will provide with which they will be able to register their Mithril key with the aggregator. So the aggregator, which is the center part, it's a kludge. Let's face it. The aggregator it's a centralized part of the system that we want to get rid of. Right now, it's a kludge. Its purpose is twofold. The first one is to simplify the registration process. So when the Mithril signers register, they register with the aggregator instead of registering on chain, which they should do. And the second thing that the aggregator provides, it provides a beacon, which is a way to synchronize the signers among each other. Because of course, each signer works independently of each other and they sign independently of each other. And so they need a way to synchronize. And of course, the way you want to synchronize is to synchronize using the chain, which requires interaction with the chain itself and to know exactly when to sign, what to sign, and you need to be sure that you are signing exactly the same bytes, down to the same bytes. And one of the things that you could think of is say, hey, yeah, that's easy. Maybe you could just sign a snapshot of the state of the of my node. The problem is that depending on the exact state of each node, you don't know exactly. You're not sure you will exactly get the same amount of bytes because, well, you could be slightly ahead of the nodes. So being your tip might be slightly different, or you might be on a small fork, or yeah, whatever. Everything that can happen. And that's the reason why what we are doing for the full node right now is to sign the actual immutable files, which are guaranteed to be, immutable and the same on every single node. But of course, the idea and the Mithril aggregator other role is to distribute the snapshots themselves. The certificates are relatively small, a few tens of Ks or a few thousands of bytes, but the snapshots are huge. Of course, the snapshot, a snapshot of the mainnet right now is something like 50 gigabyte compressed. So that's super huge. And so this role of providing a snapshot is actually the most important one from the perspective of the client, and that's where things become interesting in terms of network and interaction and roles and potential business. I would say business models or deployment models. That once we manage to make the system fully decentralized, like the Mithril signers will operate completely independently of any central authority. They will register on the blockchain, on the chain itself, and they will pose the signatures using either maybe some second, some other PubSub mechanism, maybe even something. The signatures themselves don't have to be distributed securely. They could, for example, be stored in IPFS or something like that, and be transient. Then the aggregator could be anyone. Anyone actually. The aggregator doesn't need to be trusted. That's the important thing to think about. The aggregator role is just to aggregate the signatures from the borrower signers, produce the snapshots and the certificate, and this certificate, the validity of the certificate hinges on the actual individual signatures and the keys relevant to this signature. And if the aggregator is dishonest, actually faking the keys is extremely hard, of course, because you will need to fake the actual private keys of the signers, which doesn't make sense. Hopefully it doesn't make sense. And so this means that the aggregator could perfectly be independent and work independently of the signers. And there could be multiple aggregators providing different kind of service, different level of service to their clients. The last part of the system, which is the simplest one, is the client. The client is just the thing that will use the snapshots. It downloads, it talks to the aggregator. There is an API for the aggregator. It talks to the aggregator to retrieve a list of snapshots, choose one snapshot that is of interest to it, and then start. Basically run, download the snapshot, download the certificate, verify the certificate and the certificate chain, and do whatever it wants with the result snapshot. So maybe a little demo quickly. I will go. So here is the Explorer. So this is the Explorer for Mithril. You have different networks. So here we are on. So there is a testing network for preview, another one a pre-release for preview, and there is a release a pre-prod network, which is the these are all links to the actual networks, Cardano networks. You have here different snapshots. You can see who signed some snapshots depending on the various parameters. You can see also what's the there is no Mithril stake distribution here. Maybe on a preview. Yeah. So you have here like what's the Mithril stake distribution in place at this moment in time. Not very interesting, but this is the testing network. And then you have various parameters. You can see what are the parameters. You can also see and because we also want to be able to be future proof, you can also see that there is provision in the Mithril network to upgrade the parameters, to upgrade the nodes, the signers themselves. There is the same concepts that you are familiar with from the blockchain, from Cardano, which are the so this one is slightly more interesting. It's a testing network. What does it shows? Yeah, so a bunch of pools. So this one has more realistic parameters, which will be probably the parameters from that might be used for mainnet. So that's the Explorer. There is, of course, the and how do you use it from the client perspective? I have here a quick demo, but it's very small. And you have all the instructions on the website, so you are welcome to also use. So basically, you need some you first need to download the Mithril client. Then you need to define the various parameters. So the endpoints, which are the endpoints for the API. Here, where is the API? I'm not sure if is it still there? No. Maybe it has moved. I don't remember. Yeah, here the API. So the API is relatively simple. Yes, where is it? Maybe there is a fuck up on the website. Anyways, so it's just an API for the aggregator. There is a Genesis key, which is currently, of course, in testing, very simple to use, but which later on will be actually the Genesis key that you can retrieve from a secure source. Just like the Genesis key, actually, you get when you download the Cardano node. The snapshot digest, which is what kind of snapshots, which snapshot do you want? You can then use the Mithril client to list the snapshots that are available. You can get the details of the snapshots. Maybe that's too small. Yeah, you can get some details about the snapshots that you want. Then you can download the specific snapshots. So you actually get here. You actually get the archive for the snapshot. And then once the snapshot is downloaded, so this one is a small one because it's on the pre-prod network. Then you can actually restore the snapshot. So the restoration process from Mithril amounts to unpacking the snapshot and then verifying the certificates and the signatures. So yeah, 1 gigabyte still takes a bit of time. Then it verifies the various certificates, so the whole certificate chain down to the Genesis certificate, which is of course dependent on the Genesis keys. And this unpacks a database, which is the Cardano DB, and then you can run the Cardano node like you would normally, and by pointing your Cardano node to some specific database provided by this Mithril snapshot. Where am I? So yeah, this is relatively short, but I think you get the gist of it. And of course, there is a command line interface client, but because this is an API based and this is an example of an aggregator, there could be other aggregators. There could be different ways of retrieving snapshots. We are considering, for example, maybe distributing snapshots using BitTorrent, which would make the download and the bandwidth consumption much lower, and so on and so forth. So a lot of things that would be possible, but we try to do one thing and then deliver it and then improve once we're live. So the next stage would be decentralized network to be able to have either. So this slide is slightly old. The idea was initially to piggyback on the Cardano network, but this thing's maybe a bit complicated. So probably we'll use a third-party network, recreate a peer-to-peer or a PubSub network, or reuse some existing network that we can piggyback on. Maybe IPFS, for example, or maybe other something. The thing is, like, the operation of the Mithril signers themselves and the data they rely on does not require that much security. Of course, there was always the possibility of a denial of service, but yeah, that's the thing we need to strengthen our understanding of. So the thing that I've talked about already is about the extend the usage of Mithril by providing various. So providing a Mithril signature for parts of the chain state and not for the whole chain database and chain state, like the UTxOs set or the state distribution, which could be useful for specific use cases, people wanting to do like just verification of the state distribution because they are interacting with SPOs and they are maybe doing something special with the state distribution, like for example on sidechains or specific dApps, UTxOs set to retrieve only the UTxOs I am interested in, and so on. Mithril as backbone of the voting system, and potentially even Mithril on other blockchains, because the technology is actually pretty much agnostic about the staking that is used, the staking value that is used for staking. So there is no reason why it couldn't work for other use cases. And for one example is given in the paper itself, where they say they expose or they propose a use case to use Mithril as a voting system for Bitcoin based on the amount of Bitcoin you have. And now, given some parameters, you run the VRF, the Mithril signature process to generate your signature of some values, something, and then depending on the vote, on the results of the vote, you can produce a certificate that says, okay, I voted for X or I voted for Y, and you provide a secure aggregated multi-sign voting results based on the amount of Bitcoin you have, or even just the number of votes you have. Yes. So conclusion: come play with us. This is we try to make this project very welcoming to external people. We are already talking to, or we are testing Mithril. So yeah, one important thing when you look at the Explorer here, especially in testing, in like yeah, maybe not the testing one. Maybe the preview one is the pre-release one. Yeah, this one is actually these are real SPOs, like not made up SPOs. These are real SPOs running real software. and interested in participating with us on and testing Mithril. So, and you can see here the process of aggregating the signatures for various signers. And now, yeah, we have a new snapshot, and you can see the snapshots are being signed by those pool IDs, those parties, and these are actual pool IDs valid on this network and operated by interested SPOs. So yeah, so fully open source. There is a website. You can join us on Discord. You can contribute on GitHub, and that's basically it. I hope I wasn't too long. Maybe I went a bit over 30 minutes, but sorry for that.
No, it's okay. Yeah, it was great. Great presentation. Thank you. Maybe let's leave 5 minutes for questions.
Yeah.
Any questions or comments for others?
Shoot.
Yeah, is this? I have one. Is this something that eventually all stake pool operators will have to run?
We'll have. Yeah, ultimately, that's the goal, because the value. The value of the certificate is only as valuable as the number of parties grow. So this is some kind of a discussion we are having internally, because on the other hand, you could also say, well, you know what, the stake pools are identified and they sign with the keys. So we know who they are. So you could also have some form of rely on the reputation and some form of social pressure to say, well, it's fine to have a certificate that's signed by some parties, and there is maybe no need to have everyone running the signer, as long as we have some minimum value of some threshold reached. This raises, so the next question I guess usually we have is, oh yeah, but why would they run it? What's the incentive there? What's the incentive of running Mithril? That's a very good question. I think so. This is the economics of the Mithril network is not totally solved, because basically one important thing is from the point of view of the signers, there is not much work to do. You just run a piece of software that produces signatures. It's not very high on resources. It produces the certificates every few hours, so it's not something that is compute intensive that would require a huge incentive to run, because otherwise you wouldn't do it, right? It's not like in Cardano, running a node is not that expensive, but still expensive. I mean, we know if you are a small SPO, we know that it's hard to be profitable, because, well, it really depends on the stake, and even operational costs for a kind of node are relatively high. It's a few $100, potentially a few $100 a month, which is hard to cover only by and so on. You probably know that more than I do. So the question is, where does the incentive and where the money comes from? And I personally think, and I think that's something we try to push, is the value is in the clients. I mean, who gets the value of Mithril is the clients, the one that are benefiting from getting a snapshot, getting secure data fast and secure, accurate data faster, being able to download it. So there is some economic circuits to be built between the signers, the aggregators that would provide us the actual snapshot, because the cost is also, if you are distributing a full chain like 50 gigabytes, the cost is incurred actually by the aggregator, because it's the one that is distributing the snapshot, not the signer. The signer just say, hey, here is a 64 bytes or 128 bytes string that is the hash of the state. Please distribute the snapshot. That's what I know. But the aggregator is actually the party that will compress the data and serve it over whatever medium it wants to serve, and that's where the cost is, because obviously from the network perspective, serving 50 gigabytes of data is a lot. So yeah, so there is a good question. There is a question of, okay, who will be running aggregators? Why would they do that? And that's where the question of the economic model is interesting to explore. And that's also the reason why we are trying to multiply the use cases to make sure that we try to explore the use case space to make sure that at least some of them will have the proper model to set up. Maybe it could be the voting. Maybe the being able to vote securely would be a good incentive to be able to, and the snapshots would be small enough that there is no cost in distributing the snapshots and certificates themselves, so anybody could do it, and there would be an incentive to run that. Maybe light wallet providers could be aggregators, so they could provide the snapshots and provide snapshots, and maybe deal with some SPOs or provide an incentive to the SPOs to provide the signers. So maybe there is even a market that we could create around the signatures. Say, hey, yeah, I'm glad to. I would be happy to sign your stuff. I am SPO X. I would be happy to sign your stuff, but what do I get in return? So there is, and honestly, I mean, yeah, I don't have all the answers at this stage. That's something we're exploring, and that's something we would be much interested to hear about. Also, if you have ideas, if people have ideas, even crazy ideas, why not? But
okay.
So there will not be. This probably won't be mandatory because, because I mean, we don't want to shove Mithril down the throat of everyone. And then the question is, maybe the community will find it useful enough to say, hey, that's important for the community. So as a community, we would be interested in incentivizing the SPOs to run that. That's also an option, right? And that's also why we are really building that in the open and being very, trying to engage with the community to say, hey, help us grow it, because we are the developers. I mean, I don't have all the answers. So
yeah, at the end of the day, you need people to opt into becoming a signer, right? And there's some kind of...
right now, that's for sure. You need to opt in. Maybe we could have a way to make it more opt out, which will maybe increase that. But at the end of the day, it needs to be it needs to be voluntary, because otherwise it doesn't make sense. I mean, I think that's what I think. But maybe other people have other ideas about it.
Yeah. And regarding the aggregator, so if I understand correctly, at the beginning, the aggregator will be more centralized to simplify, the process, to remove that complexity. And then you talk about how you could have multiple aggregators competing or maybe doing different things, different use case. What did you mean by having different use case for the aggregator?
But for example, I mean, one example, for example, a lot of examples. One example would be, I mean, there could be an aggregator that provides you a CDN-backed fast download, super fast download of some piece of data, and which will make it like instantly available everywhere, and provide a high speed, a high value service, where you would have another aggregator that would say, well, you know what I do is that provide the snapshot, but it's a BitTorrent and it's distributed, and I only provide the trackers, for example. That could be a way. I provide BitTorrent trackers, which is much cheaper to run, but I don't provide the full snapshots myself, or I team with other people to provide the snapshots, so that there is the download gets distributed across a number of hosts. So that's a technological dimension. That's a technological differentiator. You could have, I don't know, closed snapshot providers that would be closed. Say, hey, you know what? If you want to be able to download snapshots from me, that's a pay-per-view, or that's a subscription, or something like that. So there could be differentiators, and then there could be also differentiators on what the aggregators would distribute. So the team is currently working. So the current version, which is live now, provides a way to sign. I'm not too sure, but I think the current version, which went out last week, provides a way to sign multiple things. So you could sign. Right now, we sign the full chain, but soon we'll be able to provide a certificate just for the stake distribution, which is much more. So you could have aggregators that say, yeah, you know what? I'm not interested in the full chain. I'm interested in the stake distribution. So I specialize in some part of the system, and I provide a service on top of that. So, for example, one thing I can imagine is like if we provide a signature for the UTxO set, now as an aggregator, I could say, you know what? I got the UTxO set, and I can provide you a Merkle tree of the UTxO set with a proof that your Merkle tree, the address you are requesting from UTxO set is actually in the tree. And now I provide an additional service on top of what's the signer and what the row snapshot is actually. So that's the idea around aggregators. And the vision is to say, well, signers sign, they provide signatures that anybody can aggregate, and then the aggregators provide a service on top of the signature. Note that the signers themselves could be the aggregators. For example, we could imagine that you have a group of SPOs that say, well, you know what, we are running our own aggregators, and if you stake with us, then you have access to a Mithril site snapshot.
Mm-hmm.
That could be a model.
Okay,
So,
yeah, it's interesting. Yeah, so you become a data provider, right? And you can
yes.
then
And
use
this
those snapshots in different ways to provide data.
This lets us into the area of, okay, can we build a data layer on top of Cardano, because that's basically what it is, right? This is the embryo of data layer on top of Cardano. So Cardano provides the proof that certificates and the proof that something is there, but the actual data is stored elsewhere and distributed by another mechanism, another network, because we can't store the data on chain.
Yeah, and it's verified, so you maintain that security.
And it's trusted. It's based on the security. I mean, honestly, I didn't do the math, so I'm not 100% sure this is true, but it started as secure as I mentioned, because the stakes are the same, and the probability calculation tells us, and once again, I didn't do it myself, but the probabilities tell us that we are probably in the same area, in the same range of security that Cardano itself, because we are using the same stake and the same keys also.
Got it. Okay, so we have 5 minutes left. I think, Lucas, are you okay if we maybe the topics we're to cover, we'll cover them in a different call?
Yeah,
instead
absolutely.
Of rushing it. And maybe we can just, if there are other questions, we can spend the last 5 minutes with questions, discussion, and then we'll just end it there.
I had maybe not a question, but I just wanted to introduce myself. So I was invited to join this meeting by Murasaki-san from Emergo. So I'm from Emergo Academy, and so a lot of my interest in Mithril, and so basically this is the first time that I'm joining this meeting. So it would be nice to sort of come to know a little bit about what is the goal of these meetings. That would be really nice to know.
Yeah, sure. So we usually structure in multiple parts. This time around, it was mainly the presentation. So we usually start with the presentation from the community presenting. We had Hydra coming in. This time we have Mithril. We have Ouroboros. So we just invite developers and kind of give them a platform to showcase what they're building. So it's mostly infrastructure focused. Then the video is recorded and shared online. But as an association, we're just a members association of people building infrastructure on Cardano, building tools and APIs, and really helping mature the developer ecosystem to both help people building Cardano right now to make it easier to build, but also incentivize people outside Cardano to have a good experience when they come in, right? Lower the barrier to entry. And so we've only been started for a couple of months, and so the goal is to kind of create a space for people to communicate, and then also the second part of the call is around collaboration. So we have a couple of projects or tasks that we're trying to do across the members and trying to push forward. For example, like one thing we wanted to talk about today was having maybe a panel at the Cardano Summit. So bringing together all members of the CBIA, and then maybe have a panel or workshop that we could run at the summit and have more discussions.
Awesome. Thanks so much for that. And I really found this presentation quite interesting. I'll definitely be going through Mithril in much more detail. So probably maybe some few, in the next session, maybe I'll ask my queries in the next session, because this is something that we like to teach about, right? Ouroboros Hydra we have taught. I think Mithril is upcoming, so it's very important for Academy to teach very authoritative stuff to all the learners, so that the learners come out with the right information about Cardano protocol.
One important thing, I mean, because this is a builders and technologist arena, I think it's important to state that Mithril team, we don't pretend to have all the answers. We are building a technology. This is cool. This is interesting. We have some ideas, but we don't know, right? I mean, and we really want to. That's the reason why we are trying really to engage with the community on Discord, on those kind of meetings, spreading the word, because we want the community to. We would like to avoid the infinite trap of being a solution in want of a problem, right? So, which is often something in the blockchain space. It's something that is quite, unfortunately, a bit too common. So, we really want to make sure that what we build is actually focused on the use case. And restoring a Cardano node is a pain in the ass. Let's see it, right? Yeah, solutioning, exactly. And so we try to avoid that. So we are really targeting a narrow use case, which is not perfect, not that common, but at least we want to make sure that this works. And then we want to make sure that we won't embark into a multi-year plan before making sure the technology works great and we have a good understanding of what the needs. And then this needs to be driven by the community, by Cardano, by builders. Say, hey, yeah, Mithril is a cool technology to do X, Y, Z. I am a dApp developer. You can imagine that as a dApp developer, if you want to build, if you want to provide like a snappy reactions and the capability to interact quickly with the blockchain, with Cardano, given the actual parameter, the way the system works currently, having the ability to scale up your nodes and being able to provide, like I said, the use case of layer 2 plus Mithril allows you to scale up a Hydra cluster in minutes and not hours, which is, from the point of view of a dApp builder, if you want to provide, like, be able to scale to multiple users, is a very interesting way to think about it. And but once again, we need builders to tell us, yeah, that's what we want to do. We want to do that. That's interesting. Let's push it in that direction. But we will try to avoid like I said, forcing down the throat of people just because that's the best thing to do. We try to avoid that, and at least, and making sure we are doing it up. So please, yeah.
I did have a question. I'm not sure, how relevant it would be, but I'll just ask it anyway. So right now, if you see, I think the block time is around 20 seconds, so that the entire network can hear the block in that time, right? So one of the advantages of Mithril would be that because of the high throughput, because of forward signing, I don't know whether I'm being very accurate with the technical terms. The block time could come down significantly, right? Could that happen because of Mithril?
So that's one of the premises of layers.
Layers, yeah.
Yeah, but the idea of layers is slightly different, because to do that, you need to separate the production of data blocks from the production of ranking blocks, because that's where you got the fastest throughput of ranking blocks to be able to settle the consensus faster. And then you are using Mithril to provide also to remove the need to verify sequentially every block. And I think the idea, and honestly, I just don't know exactly how layers works. I've only skimmed through it, and I'm not an expert, but I think roughly the idea that because an input block is signed by enough SPOs and comes with a certificate, then as a node, I can adopt the block immediately. And if the ranking blocks also contain pre-computed state or pre-computed state change, then I can immediately apply the block, and then I can go faster. That's an hypothesis there. But in general, Mithril is more, I think, I'm not sure Mithril will have by itself such an impact on the network throughput. It would just be a multiplicator for scaling, but not making the network faster, but providing more use cases. Because right now it takes a while to synchronize the network. It's hard to really, I mean, it's hard to if you want to go fast, you have to go through a centralized third party, and that's not the promise of blockchain, right?
So it would make the network also more resilient if
Yeah,
there's
and
internet fragmentation or something.
And also, I mean, there are also use cases around checkpointing and snapshotting. So now you could also imagine one use case, for example, that we are thinking about is say, well, what if you are running a full node, like even a block processor, but maybe not a block processor, but a full node. You start from a Mithril snapshot, which is just the ledger state, and you don't care about the blocks. You don't care about history. You start from some state, and you know the state is correct, and then you start accumulating blocks. So you are drastically reducing the amount of size, the amount of storage you need, because you start from a node state. It's super snappy because instead of having to download 50 gigabytes, you download maybe 1 gigabyte still, but that's still important, but that's much farther. I mean, it's less than a movie, right? So it's very fast. So that
I did one more follow-up question. So
Yeah.
if I look at a block structure in Cardano, you have this SegWit kind of a format where you have your UTxO state, and then you've got your
Yeah.
ledger data, which is your signatures and possibly transaction metadata, right? So considering that the block is already split into these three sort of block segments, could Mithril also be used to sort of take only the UTxO state?
Yeah, that's
and
the idea. Yeah, that's the idea. The idea is to provide a certificate to provide specialized snapshot for part of the state. Yeah.
okay, awesome. Okay, that makes a lot of sense now.
But and that's been a big engineering effort to be able to do that relatively easy, so that the node, the signers and the aggregators can be configured to sign various stuff. That's and our next stop is the probably the UTxO set. Yeah.
Awesome.
Be able to just retrieve the UTxO set at some point in time and sign that, and then now you have a much smaller, a much reduced.
Much spiffier, much smaller, right? I mean,
yeah, the
literally
UTxO. I mean, UTxO set is large, but it's a few, probably a few hundred megabytes or something. I think something like that. Maybe not sure. I mean, depending, because it's been growing, but but it's
At
not
least
50 gigabytes.
Yeah, at the least, yeah, at the maximum. Awesome. So very
Okay.
interesting.
Yeah,
Discussion.
thank you very much for having me. And I guess have a good day or good evening or good
Thank
night,
you so much
depending
for
on where
coming
you
by.
are.
It was really interesting to hear all this insight. Discussion will be shared on YouTube and on Twitter and everything.
Thank you very much.
We hope to have you back eventually.
I mean, I'm always happy to be here. So that's cool.
Thank you so much.
You're welcome. Have a good day, everyone.
Good day.
Bye-bye.
Thanks a lot.
Is the topic for the next session already known, so that at least I can do my homework and come?
No, we'll still be, but we'll keeping you in the loop. Okay.
Awesome.
Thank
Thanks
you
so much.
See you guys. Bye-bye.
Take care.